I'm Matt Schultz. I'm one of the advisors for the club, and I'm a teacher.
I'm Alec Devlin. I'm a student from Lakeview.
And I'm Eric Seke, also an advisor and teacher at Lakeview. We're in Kenosha, Wisconsin.
Yep, just about 10 minutes north of the border of Illinois. So we're going to talk a little bit about what we do as a club, just to give you some kind of some background about what energy efficient vehicles are in the state of Wisconsin and how we can articulate that into our curriculum with our high school students. We're going to talk about the hub adapter, really that I think gained Tormach's notice. We're going to talk about other things we do with the Tormachs and in the classrooms. And Eric's going to start by talking a little bit about our high school and about the partnership and the relationship we have with Gateway Technical College.
So Lakeview partners with Gateway Technical College. We have dual credits. It's a choice high school. We are part of the Kenosha Unified School District, so we are a public high school. We offer 4 different tracks. One of those tracks is the automated manufacturing. We also have an engineering track, and that's where where both Matt and I teach classes in that area. We do information technology and also biomedical engineering. I teach a lot of the freshman and sophomore classes. The students gain knowledge on manual machining, and then as juniors and seniors, they take the articulated classes on the automated track at Gateway. And the school is the same, so we share the building, so the kids will take their regular classes there as well as their Gateway classes throughout the day. A lot of the kids will graduate with up to half of an associate's degree by the time they graduate as seniors, and then they go back and finish up the rest of their associate's degree.
Nice thing, like Eric said, having that partnership with Gateway. When we got these Tormachs, we split the bill half and half. So we were initially looking for just a lathe at the time, but because Tormach is such an affordable, great price, we were able to get both the lathe and the mill for the money that was allocated from both the university and from our school. So we kind of worked out well in our favor. Any questions about the school, what we do? So what is SMV? What is Supermileage vehicle? Supermileage vehicles are basically energy efficient vehicles. As we brought one in here, mostly people think that we're redoing real vehicles and making those energy efficient, and that's really not the case. The students are designing and building these from the chassis up to get optimum fuel mileage. We have 3 different types of cars. This year we have built our first hybrid, so we used a 50cc or 49cc kicker motor from a pit bike and an electric motor to team up together to get our first hybrid. Alec was on the senior build team with that, and he can talk a little bit more about that too when he's talking about his hub adapter. We built 2 gas cars, combustion engine gas cars. Those were getting around 300 miles per gallon, and we built 2 electric cars. And this car right here that you're looking at here, this is the 2-time, well, I shouldn't say 2-time. It's the best electric car in the state as of this year. We won both events at Fox Valley Tech College and at Road America Raceway. We switched over. Let me talk a little bit about how the competitions work, just to paint you guys a picture. With the gas engines, they weigh your fuel prior to the race, you go and do your laps, and then they weigh your fuel after. And then that difference goes in an equation to give us their fuel mileage. So we do a coast and burn style driving where the kids will burn, let's say it's going down a hill or up a hill, depending on what the driving strategy is, and we won't run that engine continuously during the race. And then the difference, I said, will go into an equation, and we'll get our calculation for mileage. So we're getting around 300 miles per gallon. We're about right around the average of where the cars are in the state. We're running a Briggs Junior 206, which is a race engine. The reason we went with that engine, even though it's giving us more power than we need, it's a kit engine, so we can put an electric fuel injection on there. There's a lot of parts that are modded in and out. That's the desire behind it. Other schools are going with like a Honda 3-horse because you only need the power. They're getting much higher mileage, so it's broken into classes, so there's a difference in the mileage. But Wisconsin right now is yet to break 1,000 at the high school level for mileage. We got close this year. I think Bowler High School got around 700 miles per gallon with their 3-horse. So it's a cool competition. The electric and the one we brought in here, it's a little bit different challenge. They get 1 hour on the course, depending on the battery style that you are using. There's seal lead acids, there's the lithiums. Depending on your batteries and the power density that you're using, you get different weights. So we ran with this car for a number of years, steel lead acids. We got 72 pounds of batteries, which made, in the back here where our batteries was, which made the tail very heavy. So we were going through a lot of rear wheels, going through some of the turns, especially at Road America and those speeds. So we switched, we were able to work with a company out of Texas and get a lithium manganese battery. If you know anything about batteries, it's the highest power density. We only get 16 pounds though. So we competed this year with that, and from the advisor standpoint, I think we could have had better runs, but we still went out and got 28 miles per gallon, or 28 miles per single charge, which the second placed car was a mile behind us. So we really pulled away. I don't think we had our best runs in. I think one time the kid went out, our senior driver went out and the battery was at like 80% charge. And then the other two races, it rained and was very uncomfortable to drive. So we had clinched the victory, so he didn't go out to set the record. But I'm excited next year to see that. I think we're really going to pull away from the other schools unless they get on the lithium bandwagon. Did you have a question?
You said power density. Did you mean energy density?
Energy density, yes, sorry. Okay, so let's talk a little bit about how, now, you guys have any questions about what we're doing with this? Okay. So I got pictured here just some of the pictures of what the students are doing. I have 20, we have 20 kids on the team, and it's an after-school club. It's voluntary. They come and be a part of it. I think Alec was the only senior this year that was a part of it for all 4 years. But the team's growing. We design and we fabricate everything. So using machines like CNC, the Tormach, we have a couple other machines at school that we use, but we have lasers for prototyping. We have the plasma tables. We do a lot of our own custom fabrication of these parts. And I think that's cool because it's really getting the students into this new technology that is preparing them for the workforce. So my job and Eric's job is not only to facilitate this club, but to give students a direct opportunity to future employment opportunities, career paths. And we're going to tell some stories about some of our students who have taken it beyond the classroom, beyond the club, and now have careers, Alec being one of them, in industry related to what they did with the club. And you can see some of the stuff that we have here. It's really unique because our school, like Eric said, is manufacturing and engineering, but we don't teach the traditional classes that you might think we would do to facilitate a club like this. We do teach the CNC, so Alec took, how many CNC classes did you take?
I took one, but I took quality manufacturing and stuff like that.
Okay, so they do have the option to take these CNC classes after they take Eric and I's classes. That we don't teach welding, we don't teach small engines, we don't teach a lot of these fabricating things that you think would need to construct a club like this. So we kind of make do with what we have. We have a great facility, we have a lot of tools, but I think engineering with what we have makes us really strong. So this was our first year. Like I said, we had an all-female team, so we had 5 females that Eric and I hand-selected from different classes that were not manufacturing or engineering students. They're actually biomed students, but they had great work ethic. They were the top in the class. They really showed some potential. Eric is lead in the state for
Technically, it's
Technically.
getting girls involved in technology and engineering classes and kind of promoting that.
Yep, Techquity is what he calls it. So he's the head at the state level of this movement. So he came and said, let's get a girls club going. So we hand-selected the girls, and they built a great car. We had to teach them how to weld, how to machine. I don't think some of them like to machine anymore because of the amount of machining that goes into this manual machining. So hopefully we'll get them into the CNC and change their mindset. We have these 2 students here are working on the electric car, changing out that, you can see that large 106 tooth sprocket that they're changing out at one of the practice sessions that we had. You can see them racing here, some welding. Everything's portable. We move these cars, we move all of our tools, we move the welders, and we kind of have to makeshift space to work in. It's a unique working environment. And then you can see us here at the race. In the state of Wisconsin, there's 4 avenues or places for us to race. We race at the big one being Elkhart Lake, Road America. How many people are familiar with Elkhart Lake? So they get to drive. You've driven on the track multiple times, which is a really cool, really unique experience. Alec was just telling us on the way up here, he went up there for an Indy race and he was listening to one of the drivers talk about how his first time driving was in the same position Alec was, testing his energy efficient vehicle at Road America. Now he's here racing. It wasn't Indy, it was Pro Mazda stuff. So it's kind of a cool experience. So Elkhart Lake Road America, Fox Valley Technical College. We used to race at Wisconsin International Raceway. We moved it now to Fox Valley Tech Colleges, has a track on site that we moved to. UW Stout and UW Platteville both have courses, road courses, that offer different unique challenges as well. But really cool, really unique experience that these kids get to participate in. So how do we utilize the Tormachs? Before we had the Tormachs, we had CNC, was it a 4-axis or?
It was a 3-axis.
3-axis.
There were little pro lights.
Little pro lights, and then we have a fryer. So we had some CNC before we got the Tormachs, but we upped it and got 2 of the machines in now. So you can see here, besides what we do with the club, the students in the classes have to come up with projects with the help of the Gateway instructor or just basic needs within the community. A lot of people from the community will call us and say, hey, we need this prototype for a part, and those students will make them in-house. Right here, these 3 students, these are 3 seniors. 2 of them on the left are actually club members. These are air bearings. So they're trying to design better air bearings as a project. So they made a couple different prototypes, which was pretty cool. They utilize both the lathe and the mill on these projects. So we're getting 2 processes going at once. And all 3 of these students, it was their first time taking a CNC class. So pretty cool projects. Bringing them in. How many people here have Tormachs? Just a few of you. How many people with your hand, keep your hand still up, how many people installed your own? Okay, so we installed our own as well. Yeah, you're raising your hand, of course you did. We installed our own as well, which was a fun, lot of work experience. The instructor of that Gateway course, Eric and I and the instructor, we rented a forklift and we got them in the building and we pushed everything into place. And then throughout, they came right when the school year started. So when the school, any teachers in here? No. Okay. Yep. It is hectic once the school year starts when you're getting machinery delivered and in place before the season or before the year starts. So the instructor chose to, for a great learning experience, ask the students to help set up the machine, which could have went in a lot of ways, but I think the caliber students we had really got into it and were able to set this machine up. So you can see them here with an engine hoist actually putting the turret into place on the lathe. And you notice there's no one, I think the instructor is taking the picture. So we really put a lot on the students at first. Before they even knew how to CNC, they were building the machines and the equipment, which I think you can speak behalf of. Did that help the process, or?
Oh yeah, definitely. Just learning how to set everything up, touching off the tools and putting them into the turret and stuff like that. Definitely was the experience.
An experience to say the least. They had to do some shimming and they learned a lot about it. So why we're here today is this hub adapter. And I'm going to pass some around here and I'm going to talk a little bit about it, and then Alec is going to talk about how we manufactured this and how he specifically, you can just pass in different directions. I'm also going to pass some stuff around about the club. Just feel free to take a look. This is one of our incentive packages that we use for the team. So first of all, this started with a need. And I'll come back to the previous slide. It started off as a need. So as I mentioned before, a lot of what we're trying to do is prepare these students for industry, for careers, career pathways, colleges, trying to tap on some interests. So 3 years ago, I worked with a gentleman named Will Lambert. He now works at Owens Industries as a consultant, but he owned a company called Form by Design. And I met him at parent-teacher conferences. His daughter was in one of my classes. I couldn't get her into the car club, but she was a biomed student. But him and I kind of hit it off right at conferences, and he was telling me what he does with engineering as a design consultant. And he said, I'd really like to get involved in your club. What can I do to help? So I started talking about some of our needs. And at the time, one of our biggest needs was retrofitting a rear bicycle spline pattern to fit, this is a typical cassette off the rear, to fit and mount these thicker sprockets. Okay, we're running number 40 chain. Some people are running 35. But to get this to mount onto a bicycle rear is not the easiest task. We ended up doing a lot of things trying to weld concentric splines on the existing cassettes. We did that for a number of years. We were throwing chains. Across the state, it's huge, huge problems. What do you guys do at MIT for this?
just built the whole thing.
You just build the whole thing. All right. A little bit different skill set, I suppose. But actually, it fits pretty well. And I'll pass this around, and you can see where this, so the diameter of this hole will fit on this cassette existing here, and then you could weld it on and tack weld it on. Not the most efficient, and be careful, this is a little bit sharp. We didn't deburr it as best as, I didn't plan on passing around, so don't cut yourself, sue Tormach. So we sat down with this design engineer, and he sat with my students, and we started speccing out a solution to this. And they went through the whole design process, the students with the engineer, on how we could come up with a solution. And the solution was, in a sense, obvious. Develop something that's going to fit into this spline pattern. This is a Shimano bike rear end hub. Pretty standard configuration. It does have a keyway, so when I pass it around, if you take it off and it doesn't mate back in, it's because there is a key, so you got to be smarter than the adapter. But the solution was obvious. EDM, a pattern that's going to match. What high schools have done in the past with their CNC was take a small 1/8 inch mill bit and they would just extend out a little bit past, but there was slop. And when you're dealing with the amount of torque and forces that these, especially the electric motors, put out, you're going to shear it instantly. So it was very problematic, these cars out on the track, trying to come up with a solution. So the key was getting this EDM broached out. Okay, I'll pass this out. So we came up with the design and we made a prototype. We 3D printed it. I don't have the 3D printed part here. I was looking for it yesterday in a mad dash to bring up, and I couldn't find it. But we sent it off to get machined at Owens. So Owens is a custom manufacturing facility in Milwaukee, and it was who he was currently working with, who Will was currently working with, and they had an EDM machine there. So they designed the first one, and I think the first one is on this car right here. They designed it with a 6-bolt array pattern to fit the sprockets, okay? And they sent me 2 of them, and we put them on the car, and they worked beautiful. We'll come back to the hub adapter in a second. The sprockets themselves, we partnered up with a company called Biofab Technologies in Kenosha, and they have a laser, and they were able to, we started designing sprockets, which until we found an auto rendering system that did it automatically, we were doing it manually. Never ever design a sprocket manually. It was. So Will actually purchased a sprocket making software. Now you can find them online free. But 3 years ago, before this whole CNC kind of automated movement really kicked it, it wasn't free. So we bought some software to design sprockets, and now we have a company who made these for free. So when I talk about selling these, remember that name, because they made a bunch of us for free. And I'll pass this around here. Okay, so for the first year, we had this company make them for us. And I invited Will and some other members of the team to help, or to the race to see what we were doing, what it is this competition was, to kind of just show them their part in action. And when Will came, he started looking at all the other cars. So there's about, if you look in that packet, here's a picture, an aerial view of Road America from the top. There's about 80 cars that compete as well at this competition. So he was looking at these other cars, trying to see what these solutions were, and no one had a solution that was as rigid and durable and strong as us. So he said, Matt, why don't we make these and sell these? I'm like, well, that's great, because you did all the work. You want to make them? Sure. So for that second year, he made us, I think, 15. Owens donated the machine time, the EDM time. I think Will might have paid for the lathe work to get that turned out. And then they donated them to us, and we sold them for a fundraiser. Okay, so it was going great. So we had about 10, out of the 15, we sold 10 of them to different cars in the state. So we had 10 cars with our parts on them, which is real cool when you're at a race to see another school running your parts on your car. So that next year, we got the Tormachs. And I spoke with the instructor, Mr. John Nelson, who's a Gateway teacher who couldn't make it up here today. He's at the cabin, lucky. I spoke with him about trying to integrate this into the class. How can we do this and spread the word about CNC to your students and have an a real-life application to this? So we showed them design, and that is where Alec came in.
Yeah, so we got these new Tormach lathe, and we got a Tormach mill that we just got during the year. And so basically, Mr. Schultz came to me and said, hey, how would you feel about machining these? And I was kind of, sure, I guess, because I was just kind of doing my own thing. And Mr. Nelson's class. So basically, we already have one machine, so he pretty much handed it to me and he told me go nuts. So he ordered stock. He ordered 4-inch discs that were cut up into 2-inch slabs, and so I took those and I wrote my own program on the Tormachs, and I machined them from scratch. So
Here's his code.
Yeah.
He wrote it all no cam.
yeah, so I wrote all that. There was actually it was a 3-step process. Because these discs are 2 inches, he had to flip them in the lathe. So basically, I wrote one program for the first side, and then I machined 24 parts on the first side, and then I'd flip it, and I'd machine the other side. I had a tolerance of plus or minus 5 thousandths, which at first wasn't easy to hit, but once I started working with the Tormachs a little bit, they have built-in wear offsets, so they have cutter counts built into it, which I thought was really nice. It was a nice touch, and so after machining, they took about 8 minutes a piece for one side, so it took me a little while, but they were a good learning experience. I definitely had a lot of fun with them, and after I machined both sides of them, I actually wrote another program to drill and tap. So I wrote a can cycle. And pretty much all it did was it came around, it made lightning holes, and then it drove and tap holes that bolt up to the sprockets. So you can see both sides and even. So I had to write 2 programs for that. I had a little radius right here and that chamfer at the top. But other than that, it was pretty much just facing and turning. And
You want to talk about the milling application?
yeah, sure. So the milling application. So basically, I made a set of my own jaw blanks. I wrote a program that would come in and it would machine the radius of this part. In order to get the proper distance into the jaw blanks, I had a 4-inch gauge block, and all I had to do was I had the machine come around and machine the radius of the part. But then we ran into a problem where the machine is drilling and tapping, but it's gonna crash into the jaw blank. So I came in and I just took a 1-inch end mill and I just cut out a couple indents to allow chips and the coolant to pass through without the tap crashing into the jaws. Those jaws were like $60, but I mean, in terms of being able to hold the part in and run 24 parts accurately, it was way worth the money, because if I just ran it in a regular set of vices, it would have definitely been a haggle touching off every time. So.
Okay, so thank you, Alec. Any questions for Alec about making this? It's pretty impressive. A senior, his first year, coming in, writing. The instructor, we have CAM, we use Mastercam, we use HSM from Autodesk, but the instructor wanted him to do it manually. So
did EDM with one?
Pardon?
You EDM with one?
Yes. So I'm going to talk a little bit about the EDM process. What did did you drill that out before they EDM'd it?
Yeah. While I was doing the can cycle on the mill, all I had to do was just drill a 3/4 inch hole, or not 3/4 inch hole, 1/4 inch hole, so that way the wire EDM operator can feed the wire through.
Did you have a question?
It's the same one.
How long does it take
To handwrite it, 2 days per code, I think. I was only in this class for 2 hours or something, so call it 46 hours.
And why did you handwrite it?
I handwrote because at the time I didn't know the programming on the Tormachs. We had just got them, and I had on the computers we have a program called CNC Base that kind of like helps you proof out the program without crashing the machine. So I just kind of went with that.
Anybody here still handwrite code? Something? Yeah. So something cool that I think is this part's awesome and the selling it was great, but I think what I take away from the coolest part of the story is Alec now works at Slater Incorporated in Kenosha as a CNC operator. So he got a job there working during school, and he would have to remove himself from the from work to participate in the club because I wouldn't let him leave club. But he would work Mondays and Wednesdays till he works second shift, so till they only let him stay till 10, not to the 1 that it goes to, right?
Yeah.
But he started, and he's the CNC programmer there. Now he works there full time in the summer, and then he's going to be going to school back at in the fall at Gateway. And they agreed to help him or be good with his schedule so he could do both. It gets better though. So we outsourced this to Owens still that last year to EDM because we don't have an EDM machine in the school. The EDM operator at Owens is his brother Derek, and Derek was on the club for 3 or 4 years prior to Alec being on the club, and we toured Owens, or him and his dad and his brother toured Owens with Will to just kind of show him the process. Well, Derek liked what he saw. Will, who was our mentor, really liked Derek and his work ethic, so they gave him a job. Now he's the head EDM operator. So last year when Alec was making these in-house, we were sending him off to take him home, give him to his brother, and his brother would EDM them at Owens for free. So it's this brother working together process with industry, and it was just super cool. So we sold these to other high schools. Here's some of the marketing material that we have. We do a lot of this stuff digitally now because I'll send out stuff on the state or listserv, and instructors will go on and they'll fill out a Google form that I have with what they want. These are some paperback copies, but they would fill out what they would want. Here's our marketing material, and the orders would come in. And we had a certain sale date that we needed them by, so we could start making them. I had Alec start. Here's a picture of Alec working in front of the machine with them. I had Alex start making them before we even sold them because I knew that they were going to be popular. So he made 24. We sold 20 of them. The material, I just did just a basic breakdown to see how it worked as a fundraiser because we're self-funding. None of us right now are wearing this year's shirts, but we have 36 corporate and industry sponsors. Last year we had 20. This year we have 36, and Tormach is one of our sponsors, thank God now. So we can do some cool stuff with mostly tech service, getting them to come down and answer some complicated questions that we have. But other than that, we're self-sufficient, self-funding. This year we raised $36,000 to run the club. And some of that came from this. So we banked $3,300 from this. We had initial investment of $670, and basically the aluminum was the biggest cost. We had to buy some hardware from the hardware store. But we sold them for $200 a piece. We did sell sprockets separately. So some of the sprockets that I passed around, we had from 42 to 106 tooth in increments of 2, plus a skip tooth, sprockets available for people to buy. So some people actually bought the sprockets and didn't buy the hub adapter. They wanted to make their hub adapter themselves. But we sold those for $20 a piece, which was, we could have sold them for far more, but BioFab donated all the material and time on that. So we netted with this $3,330. So not bad for, we're not doing car washes, we're not doing bake sales, we're doing things that are real, giving these kids some experience. So talk about a cool experience for the team, the club, and helping out the other schools. Any questions on the hub adapter itself?
I think that's a pretty fair price that you're selling it for.
Yep. And we did.
Reasonable.
It's super reasonable, especially with if we were to do a price for the EDM operator, it would be far more than $200. But because I had it donated, we were able to. And really, the Wisconsin Supermileage Vehicle Association, or WEVA, Wisconsin Energy Efficient Vehicles, all of us advisors, we really want to work together, help out. We piggyback. We're like any other engineer. We piggyback off of everyone's success and what they're doing. We share secrets. We're like an open source. In the hopes that we'll just continually to advance and break that 1,000 miles per gallon at the high school level in Wisconsin. But we share stuff. At the races, it was cool. Guys were coming up to me, kids were coming up to my kids saying, hey, we had a 52 sprocket, but we need to gear it down a little bit. Can we get a different sprocket? And we were changing out sprockets and giving team sprockets. I think we didn't get some back, but whatever. Just a real cool experience to get these kids doing this. Any other questions about that? So this summer, Eric and I hosted at our school a camp for the advisors. Every summer, the association tries to host a camp, whether it's building cars, which we've done before. We've built 2 cars for the last 3 years at different high schools across the state. We have a week-long build where advisors get together. We camp out, we cook out, we spend 15 hours literally in the shop building 2 cars in 1 week. Real cool, real neat experience. It's like the monster garage for high school teachers. It's neat. But this year we opted to host one at our school, a 2-day workshop where we designed, we already designed it, but we fabricated and put together, we call it a dyno, but it's really not a dyno because we're not really getting too much feedback yet. That's stage 2. But basically it's a roller set that goes on the bottom of the vehicle so we can apply it. We just hold it up and show it off. Okay, so it's 2 3-inch rollers, heavy-duty pillow blocks, and then if we flip here, does anybody know what this is? And if I told you already, don't answer. Power steering pump. Anybody know the make and model?
General Motors.
It's an old General Motors. It's out of an old 87 Suburban, or 80 Suburban. And we picked this because we could get a bunch of them in bulk. But basically, we have our power steering pump, we have a pressure regulator, then we have a valve so we can gate the flow, so we can get more force, and we can apply more load to the electric motor, to the gas engine, or we can just use it to drain our batteries. Cycling your batteries when you're working with AGM or sealed lead acids, your batteries aren't awesome when you first buy them. You actually have to condition them, which most people, you look surprised, right? Did you know that?
No,
Yeah.
I did not know that.
Yeah, so we were running lithium, or not lithium, we were running yellow top Optimas, and when you buy them, they're not at peak performance. You actually have to cycle them, and the Optimas, you don't get the best power until about 25 cycles in. So to cycle those batteries, if you have a kid driving around for an hour every day in the parking lot, sure, he's going to love it, but your nerves are going to go nuts. So putting something, and especially with the Wisconsin weather, being something that you can test in-house with your cars, none of the advisors had. So we put our heads together and we designed this. We made a prototype. And this is actually piggybacking off of high school, a teacher named Dwayne Elfring at Barneville High School. Anybody know Dwayne Elfring? Nope. Brilliant guy. He's the backyard mechanic, a farmer. He actually took this power steering pump out of a car and put this together, and that's how we kind of got this idea. But we kind of polished it up and made it into a camp that we could do it. So what we did with the Tormachs was we had to make these rails for the pillow blocks to fit in. And this plate is steel. We cut it on our plasma table. The blocks that raise it up to allow the ground clearance for the rollers to work, we had to raise them up. So this is steel, and we didn't want to have steel up here because of the machining process, so this is actually aluminum. So this was a perfect application because we wanted to tie in, we already had tied in the laser, we had tied in some welding, we tied in our plasma table, we wanted to tie in the CNCs because a lot, other than just getting instructors, to come together and do this, we want to share our knowledge on the equipment that we have and let other people know that there's things you can do with the equipment you have to make parts. So we wanted to really tie in a CNC aspect. So that's where we turn these down with aluminum. And there's different, it's hard to see, but there's 3 holes here, so we can actually move these. So if you're running like a 20-inch rear versus a 26, so you can actually move these rollers. And the Tormachs, we started out with square stock, and they were just drilling and tapping. So it's pretty simple, pretty easy, but for a lot of these instructors, the first time setting up their machine, and they might not be running the same equipment as us, but getting them to run through it. And we actually, we made this code with Inventor HSM. Anybody use that? I saw something on Fusion 360 here, so I'm excited to see how that can be adaptive in. But the HSM it's a CAM software that's a piggyback off of Inventor. Download it, it's free, but we're an Autodesk school, so the kids are really savvy with the Autodesk. So trying to teach them all these other different applications sometimes can bog it down. I don't know about you guys, but Eric and I probably have 30 different programs that we need to know how to operate to use the equipment in our lab, and it's a nightmare. So the HSM was a great software for the kids to learn, but also the advisors to see. It's very easy to write toolpaths for basic, simple parts like this. So we did that. And we turned those down, and you can see this is the guy on the left side here. This is Matt Vincent. He couldn't be with us today, but he kind of led that. project, and every guy, we had, how many attendees did we have? 16 attendees, so we had to turn, so all day, for those 2 days, we were turning out these parts. So it's pretty cool. This is another part. I'll just wait to hit play on it. This was a seal puller for, I don't know what year, 55 Cadillac that one of the fathers of one of our teachers said, hey, I need this part made. You know, I don't want to spend this money. It seems pretty simple. Can you guys make this part? It'd be a great learning project. So they brought it in. One of the students made a couple attempts at it, couldn't get it right. So Alec had to come in and made this part. You want to talk a little bit about it?
Yeah, sure. So basically, one of our instructors, Brian Keeler, came to me and said, hey, you know, I'd like to give my dad a Christmas gift because he's having all this trouble restoring his 55 Cadillac. So he gave me a drawing that was from Germany, so it was all in German and in millimeters. So after I got done converting it over, I went in and I machined it out of steel stock. I had a tolerance of plus or minus 10 thousandths. And then it was pretty much just all done on the lathe. All that needed to be done was the hour diameter, and then they had a bore that needed to be done. So I did that on the lathe, and then after that, it needed a slot to be able to compress. So there's actually a hole at the top that you would thread a bolt into, and that would actually pull the two jaws apart on the puller. So I did that on the mill. I cut the slot, and then I drilled and tapped it.
We're really trying to prepare the kids for this next level, whether it's industry, whether it's the workforce, but trying to give them some experience on the equipment that we have. So that's our story. Any questions? Nope. Well, feel free if you see either of us to stop and ask us, but definitely come up here. I think it's lunch after this, so you're probably going to run out. Well, we got 15 minutes. So come up, check out the car, ask any questions you have, but thanks for having us.